They look beautiful from afar, brilliant, majestic, the jewels of the cosmos. But some stars hide a dark secret beneath their radiant glow. They are cosmic executioners. Astronomers call them killer stars because their very existence means death for anything too close. These are not peaceful suns like ours. They are violent forces of destruction, capable of wiping out planets, atmospheres, and even entire solar systems. Every star is a furnace of unimaginable energy, but killer stars are different. They cross the line between creation and annihilation. Their radiation burns so intensely that even the toughest materials in the universe cannot survive near them. These monstrous suns emit lethal doses of gamma rays, X-rays, and particle storms powerful enough to sterilize worlds. To orbit one is to dance on the edge of death. The name killer star isn't poetic exaggeration, it's scientific truth. These stars don't just end lives, they erase them completely. In astronomical records, there are countless systems where planets once existed, but now only dust remains, vaporized by their sun's fury. The universe may look calm through a telescope, but in these zones, chaos reigns supreme. For scientists, studying these stars is like observing a cosmic predator in its natural habitat. They learn how destruction works on a galactic scale, how radiation travels across light years, and how fragile the concept of safe distance truly is. In the cosmic jungle, not every sun gives life. Some exist solely to take it away. And yet, despite their danger, these killer stars are mesmerizing. Their explosions light up galaxies, their energy reshapes cosmic structures, and their presence reminds us that beauty in space is often intertwined with unimaginable violence. But how does an ordinary star transform into such a deadly monster? How an ordinary star turns into a lethal threat. Every star begins its life as a cloud of gas and dust, pulled together by gravity's invisible hand. When the pressure becomes immense, nuclear fusion ignites, hydrogen fuses into helium, and a star is born. For billions of years, it shines peacefully, balancing gravity pulling in and fusion pushing out. But even stars have lifespans, and when their fuel runs out, the balance breaks, and death begins. As a star ages, it becomes unstable. It starts burning heavier elements, swelling into a red giant and devouring nearby planets. In this phase, the star becomes increasingly volatile, throwing massive solar flares and waves of radiation into space. The once nurturing light turns cruel and unpredictable, a storm of energy that no world can withstand. When the nuclear fuel in its core is exhausted, gravity wins the battle. The star collapses in on itself, crushing matter so tightly that temperatures skyrocket. What happens next depends on the star's mass. Smaller ones fade quietly, but larger ones explode spectacularly. These detonations are not gentle deaths. They're violent transformations into something far more dangerous. Some become supernovae, releasing more energy in seconds than our sun will in its entire lifetime. Others collapse into neutron stars or black holes, the ultimate killers of the cosmos. Each transformation creates new forces, magnetic fields, and radiation levels that redefine destruction itself. From a nurturing sun to a merciless destroyer, the transition is as dramatic as it is terrifying. And so, an ordinary star, once the giver of light and warmth, becomes a cosmic weapon. Its death is not a quiet whisper, but a deafening roar that echoes through space for millions of years. The universe's cycle of creation and annihilation continues, and new killers are born from the ashes of the old. The most destructive types of stars in the universe. Not all stars are born equal. Some are calm and stable, like our sun, while others are born doomed to die violently. Among these, 4 stand out as the most destructive: white dwarfs, supergiants, pulsars, and magnetars. Each represents a different kind of chaos, a different path toward annihilation, and each one is more terrifying than the last. White dwarfs are deceptively small, but deadly. They're the remnants of medium-sized stars that burned through their fuel and collapsed inward. Though no larger than Earth, a teaspoon of white dwarf material could weigh tons. Some of them feed on nearby stars, stealing their matter until they explode as supernovas, the ultimate act of cosmic cannibalism. Supergiants are the behemoths of the cosmos. A single supergiant can be hundreds of times larger than our sun, glowing with an intensity that makes them visible across galaxies. But their beauty hides instability. When they die, they don't just fade, they detonate, releasing more energy than billions of nuclear bombs combined. Then come the pulsars, spinning corpses of collapsed stars. They rotate hundreds of times per second, shooting deadly beams of radiation like cosmic lighthouses. Anything caught in their path is obliterated instantly. Pulsars are the universe's most precise killers, silent, rhythmic, and unstoppable. And finally, there are magnetars, the most dangerous stars ever discovered. Their magnetic fields are 1 trillion times stronger than Earth's. A magnetar's explosion could erase data on every computer on our planet if it happened within a few light years. These are the ultimate monsters of the cosmos, where even atoms struggle to exist. Each type of killer star tells a story about energy pushed to its absolute limit. Together, they paint a picture of a universe both beautiful and brutal, where destruction is not a mistake but part of nature's grand design. But none of these deaths compare to the sheer chaos of what happens next, the titanic detonation known as a supernova. Supernovas, explosions that annihilate everything for millions of miles. When a massive star reaches the end of its life, it faces one final spectacular act, a supernova. In a single instant, its core collapses and the outer layers are blasted into space with unimaginable force. The explosion shines brighter than an entire galaxy, releasing energy equivalent to all the sun's output over billions of years, in mere seconds. If a supernova occurred near Earth, it would vaporize our ozone layer and bathe the planet in lethal radiation. Luckily, the nearest potential supernova candidates are far away, but far in cosmic terms is relative. Scientists constantly monitor stars like Betelgeuse, a red supergiant on the verge of collapse, waiting for the moment it detonates. During a supernova, temperatures can soar to billions of degrees. Elements like iron, gold, and uranium are forged in the explosion's heart, the building blocks of planets, life, and even us. Every atom in your body heavier than iron was likely born in one of these violent deaths. In destruction, the universe finds a strange form of creation. But the blast wave doesn't just scatter elements, it tears apart everything nearby. Entire solar systems can be obliterated, planets stripped of their atmospheres, moons melted into debris. Radiation travels across light years, sterilizing anything unfortunate enough to exist within range. It's cosmic devastation on a scale beyond comprehension. For a brief moment, however, a supernova is breathtakingly beautiful. Telescopes capture its glowing remnants, expanding clouds of gas like colorful ghosts drifting through the void. These remnants tell astronomers the story of the explosion, how it happened, how fast it spread, and what new matter it created. And yet, as magnificent as they are, supernovas are only the beginning of the story. Some stars don't just explode, they go beyond, releasing forces so extreme that not even light can escape their aftermath. These are hypernovas, the universe's most violent events where destruction itself evolves into something even more apocalyptic. Hypernovas, when stars die beyond explosion. If supernovas are destruction incarnate, hypernovas are their overpowered cousins, the universe's ultimate detonations. A hypernova releases up to 10 times more energy than a typical supernova, unleashing a cosmic burst so bright it can be seen across billions of light years. These are the loudest death screams of massive stars, echoing through the void. A hypernova begins when an extraordinarily massive star collapses under its own gravity. Unlike smaller stars, it doesn't stop at explosion. Its core collapses into a black hole, while its outer layers are ejected at near light speed. The result is a massive shockwave that distorts space itself and sends ripples of energy called gamma-ray bursts across the universe. Gamma-ray bursts, or GRBs, are the deadliest forms of radiation known. A single GRB aimed at Earth from thousands of light years away could erase the ozone layer and trigger mass extinction. Thankfully, space is vast, and such bursts rarely target us, But the possibility reminds scientists just how fragile life is under the cosmic crosshairs. For a few seconds, a hypernova can outshine an entire galaxy. It's the most extreme event a star can experience before becoming something else entirely, a black hole or a magnetar. This final transformation marks the end of the star's physical existence, but the beginning of its influence, as its remnants shape new stars and galaxies. To astronomers, hypernovas are both terrifying and fascinating. They prove that the universe is not static. It's alive, constantly tearing itself apart to rebuild anew. These titanic deaths recycle matter into future worlds, turning destruction into the raw material for creation. Without them, the universe would be cold, empty, and lifeless. It's strange to think that somewhere, right now, a hypernova could be detonating silently in the distance, its light yet to reach us. We wouldn't see it for millions of years, and yet it already happened. In space, even the past can still be on its way. But what's left behind after these explosions is just as dangerous. When the dust settles, something even denser, darker, and more mysterious can emerge. A neutron star, the densest object known aside from black holes. Neutron stars and their deadly magnetic fields. When a star collapses after a supernova or hypernova, it can become a neutron star, a cosmic remnant so dense that a teaspoon of its matter would weigh billions of tons. These are stars reduced to their atomic cores, where protons and electrons merge into neutrons. They are small, only about 20 kilometers across, but their gravity and magnetic fields defy comprehension. A neutron star spins rapidly, often hundreds of times per second, because its core shrank but kept its angular momentum. This rotation, combined with an insanely strong magnetic field, creates beams of radiation that shoot from its poles. To observers on Earth, it appears to pulse rhythmically, which is why some neutron stars are called pulsars. The magnetic field of a neutron star can be 1 trillion times stronger than Earth's. It can strip atoms apart, distort molecules, and even alter the behavior of space around it. Any planet unlucky enough to be nearby would be shredded by radiation and tidal forces before even reaching its surface. Despite their danger, neutron stars are marvels of physics. They're natural laboratories where the laws of nature break down, where gravity, quantum mechanics, and relativity collide. Studying them helps scientists understand the fundamental structure of matter and possibly the nature of space-time itself. Neutron stars are also the source of some of the universe's most powerful explosions. When two of them collide, they create gravitational waves that ripple through the fabric of reality. Such collisions forge gold, platinum, and other heavy elements that later become part of planets and even our bodies. So in a poetic way, the violence of neutron stars is the reason we exist. The gold in a ring, the metal in your blood, the elements in your bones, all born from cosmic destruction. The universe, it seems, creates beauty through catastrophe. Yet, among all the deadly remnants of dying stars, one stands above them all, more magnetic, more explosive, and more unpredictable than anything else. These are the magnetars, the final bosses of stellar evolution, capable of wiping clean entire regions of space. Magnetars, the most dangerous suns ever observed. If neutron stars are deadly, magnetars are apocalyptic. They are the rarest and most powerful stars known, the ultimate evolution of stellar destruction. A magnetar's magnetic field is so intense that it could erase data on every computer on Earth from halfway across the galaxy. In the hierarchy of cosmic threats, these are the absolute monarchs of chaos. Magnetars are born when a massive star collapses but spins so fast that its magnetic field amplifies to unimaginable strength. This field, a quadrillion times stronger than our planet's, twists space around it and stores more energy than our sun will emit in its entire lifetime. Even light itself struggles to behave normally near one. Occasionally, magnetars unleash starquakes, sudden rearrangements of their crust that release colossal bursts of gamma radiation. In 2004, a magnetar called SGR 1806-20 emitted a flare that momentarily altered Earth's ionosphere from 50,000 light-years away. If it had been closer, our planet would have been sterilized instantly. To visualize their power, Imagine a magnet so strong it could rip metal out of your bloodstream from millions of kilometers away. That's a magnetar, raw magnetism and gravity merged into one destructive entity. The very atoms near it are torn apart, as if nature itself can't withstand the pressure. Despite their danger, magnetars play an important role in astrophysics. They help explain fast radio bursts, mysterious millisecond-long signals that flash through space without warning. Many of these bursts are believed to come from magnetars releasing magnetic energy like cosmic lightning strikes. To astronomers, magnetars are like living paradoxes, small yet unimaginably powerful, short-lived yet eternally significant. They are the universe's reminder that even in death, stars can roar louder than ever. And their wrath doesn't stop with themselves. The radiation they emit can obliterate entire worlds orbiting nearby. How stellar radiation destroys entire planets. Imagine standing on a planet that orbits too close to a killer star. The sky isn't blue, it's burning. Every second, deadly rays of high-energy particles pierce the atmosphere, tearing apart molecules, boiling oceans, and sterilizing everything that once lived. This is the brutal reality of stellar radiation, the invisible killer of planets. Radiation from stars comes in many forms: ultraviolet light, X-rays, and the deadliest of all, gamma rays. When a star becomes unstable, its energy output can increase 1,000-fold. Atmospheres are stripped away in days, oceans evaporate, and rock melts into glass. Even magnetic fields can't protect a planet from such ferocity. Planets orbiting too close to massive or dying stars face certain doom. Their skies are filled with solar flares larger than the planet itself. Waves of plasma travel outward, scouring everything in their path. It's not just heat that kills. It's radiation so strong it can break apart DNA or vaporize atmospheres entirely. Scientists have discovered exoplanets scarred by such destruction. Using the Hubble and James Webb telescopes, they've seen worlds where the night side glows red from continuous bombardment, and the air literally leaks into space. These zombie planets orbit dead or dying stars, stripped bare but still clinging to existence. One of the most haunting aspects of stellar radiation is its silence. There's no explosion, no warning, just an invisible flood of energy sweeping through space. By the time a planet's atmosphere reacts, it's already too late. Life vanishes, leaving only dust and rock behind. And yet, radiation is also a paradox. It destroys, but it also creates. The same energy that wipes out planets can forge new elements, ignite nebulae, and trigger the birth of future stars. In space, death and creation are part of the same eternal cycle, and nowhere is that more evident than in systems ravaged by killer suns, real cases of star systems destroyed by their own suns. The idea of a star annihilating its own planets might sound like science fiction, but it's not. Astronomers have observed multiple systems where this nightmare unfolded in real life. Using telescopes like Kepler, Hubble, and the James Webb, scientists have caught stars in the act of devouring their children. The cosmos, it turns out, can be a cruel parent. One haunting example is WD 1145 Pulsar 0117, a white dwarf located about 570 light-years away. When astronomers studied it, they discovered something shocking: traces of vaporized rock and metal swirling around it. The conclusion? This star had eaten its planets. What once were solid worlds had been torn apart and reduced to cosmic dust. Another case involves a red giant called T-Umi, observed expanding and contracting violently as it nears death. Its radius grows so large that it swallows any planet within millions of kilometers. Worlds that once thrived under its light now spiral inward, melted by heat and crushed by gravity. A slow, fiery execution. Even more terrifying are systems where stars collide. When two stars merge, their combined energy can trigger massive explosions, obliterating everything nearby. Scientists believe this is how some of the brightest phenomena in the universe, like superluminous supernovas, are born. In those moments, whole solar systems are erased from existence. But sometimes, destruction leaves behind beauty. The debris from shattered planets forms glowing disks around their killer stars, like cosmic graveyards illuminated by starlight. These remnants tell astronomers what kind of planets once existed and how completely they were destroyed. For every system we've found like this, there are countless others hidden in the darkness. The universe doesn't hesitate. It creates, destroys, and rebuilds without remorse. And when we look up at the stars, we can't help but wonder, could our sun ever become one of these killers? What would happen if the sun became a killer star? It's comforting to think of the sun as our gentle giver of life, but even it has a dark destiny. One day, billions of years from now, it will become a red giant, swelling to hundreds of times its current size. When that happens, the inner planets, including Mercury, Venus, and possibly Earth, will be engulfed by its fiery expansion. As the sun begins to run out of hydrogen, it will grow unstable. Its outer layers will expand outward, and its core will heat up dramatically. Solar flares will increase in size and frequency, turning the calm blue sky into a storm of radiation. Satellites would fry, power grids would collapse, and Earth's atmosphere would start to disintegrate. Eventually, oceans would boil, and the planet's surface would glow red hot. Mountains would melt into rivers of magma, and the air itself would be stripped away. Earth would become a barren rock, scorched beyond recognition. Even Mars, further out, might not escape the inferno. After devouring its inner planets, the sun would shed its outer layers into space, creating a glowing planetary nebula, a beautiful shell of gas marking its own death. At the center, the remaining core would shrink into a white dwarf, glowing faintly for trillions of years as the last embers of our once golden star. This may sound apocalyptic, but it's also poetic. The atoms from Earth, from oceans, rocks, and even us, would drift through space, possibly forming part of new worlds. Death in the universe is never the end. It's transformation. The sun's destruction would eventually give birth to the next generation of stars. It's humbling to realize that even our life-giving star is mortal. One day, its warmth will fade, and silence will fall over the solar system. But until then, we bask in its light, knowing that we live in the calm before the cosmic storm. How scientists detect and study killer stars. For centuries, humanity looked up at the stars with awe, but only in recent decades have we learned how to listen to their violence. Modern astronomers use an arsenal of tools to hunt for killer stars: space telescopes, spectrometers, X-ray detectors, and gravitational wave observatories. Each one reveals a different layer of the universe's hidden fury. Unlike ordinary stars, killer stars often betray themselves through their unpredictability. They pulse, flare, and erupt in ways normal stars don't. When astronomers detect sudden spikes in gamma rays or X-rays, they know something extreme is happening. Instruments like NASA's Chandra X-ray Observatory and ESA's XMM Newton specialize in finding these cosmic predators. Another key tool is spectroscopy, the study of light. Every element emits a unique fingerprint of wavelengths. By studying the light from distant stars, scientists can detect unusual radiation patterns that indicate instability or violent magnetic fields. Sometimes they even spot the chemical signatures of destroyed planets orbiting their remains. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope take this even further. They peer into the aftermath of stellar explosions, analyzing the glowing debris clouds left behind. These remnants tell stories of death and rebirth. What elements were created, how fast they spread, and what's forming in their wake. On Earth, observatories such as the Very Large Array and ALMA detect radio waves emitted by pulsars and magnetars. These faint, rhythmic signals allow scientists to measure the rotation speed, magnetic field, and energy output of these cosmic engines. Each pulse is a heartbeat from a star that should be dead, but isn't. And then there are gravitational waves, ripples in space-time detected by observatories like LIGO and Virgo. When neutron stars or magnetars collide, they send out these waves, confirming the unimaginable power of their interactions. Each detection expands our understanding of how violent, and yet how precise the universe truly is. Through all this, astronomers have learned something humbling. Even the most destructive stars follow patterns. Their chaos is governed by physics, their fury bound by cosmic law. Studying them is like watching the universe write its own story in light and energy, one cataclysm at a time. The role of killer stars in creating new elements and galaxies. It might sound ironic, but the same stars that destroy everything around them also create everything we know. When killer stars explode, they scatter elements across the galaxy: carbon, oxygen, iron, gold, uranium, the very ingredients of life. Without their deaths, the universe would be a sterile sea of hydrogen and helium. Supernovas and hypernovas act like massive cosmic forges. In their final moments, the pressure and temperature inside these stars become so extreme that atoms fuse into new elements. When they detonate, these elements are blasted into space, mixing with gas and dust to form new solar systems, and eventually, new life. Every planet, mountain, and living being owes its existence to a dead star. The calcium in your bones, the oxygen you breathe, the iron in your blood, all were born in the heart of a killer sun. Destruction, it turns out, is not the enemy of creation, it's its prerequisite. On a galactic scale, killer stars shape entire regions of space. Their explosions compress nearby gas clouds, triggering new star formation. They also send shockwaves that sculpt galaxies, carving out beautiful nebulae and spiral arms. Without these violent deaths, galaxies would stagnate, and the cosmic cycle of renewal would cease. Even black holes, the ultimate graves of massive stars, contribute to creation. They power quasars and galactic jets, releasing more energy than any other source in the universe. In their own dark way, they fuel the birth of new stars far beyond their reach. So while we call them killer stars, they're actually the architects of existence. Every explosion is both an ending and a beginning, a reset button for the cosmos. Without their fury, there would be no light, no planets, and no us. In the grand design of the universe, even death serves a purpose, and killer stars are its most dramatic reminder. Why killer stars are essential for the universe. It may sound paradoxical, but without destruction, the universe could not exist as we know it. The death of stars, especially the most violent ones, fuels the cosmic balance between chaos and order. Killer stars are not villains. They are part of a grand mechanism that keeps the universe alive and evolving. Each explosion, each flare, and each magnetic outburst is a reset button for the cosmos. These events redistribute matter, energy, and elements across space, ensuring nothing ever remains static. Without them, galaxies would fade, stars would burn out quietly, and the universe would lose its dynamic beauty. Consider this. Every molecule in your body was forged in the heart of a dying star. The iron in your blood, the calcium in your bones, even the carbon that makes up life itself, all of it was once part of a star's final breath. When killer stars die, they don't just end their own story, they start millions of others. On a galactic scale, their explosions ignite new nebulae, colossal clouds of gas that give birth to new generations of stars. The Milky Way itself is shaped by countless supernovas that have lit up the sky for billions of years. Each one leaves behind trails of energy, matter, and possibility. So in a poetic way, killer stars are both destroyers and creators. They embody the dual nature of the universe, violent yet nurturing, deadly yet essential. The cosmos thrives not in calm, but in conflict, in the eternal dance of birth, death, and rebirth. This is the beauty of cosmic balance. Every act of destruction echoes forward, building the foundation for what comes next. The universe's most terrifying forces are, paradoxically, its most generous. And in that realization we see ourselves, fragile, fleeting, yet made of the same chaos that lights the stars. But what if this balance were to shift closer to home? What if one of these stellar monsters appeared near our solar system? The thought alone is enough to make astronomers lose sleep. What would happen if a killer star was near Earth? Imagine looking up one night and seeing a new, blazing light in the sky, brighter than the moon, growing every day. At first, it would seem beautiful, but soon, scientists would realize the truth. A killer star has drifted dangerously close to our cosmic neighborhood. The countdown to catastrophe would begin. If a magnetar or supernova occurred within just 30 light-years of Earth, the results would be apocalyptic. In seconds, intense gamma radiation would strike our planet, destroying the ozone layer and flooding the surface with deadly rays. The skies would turn violet, electronics would fail, and life would vanish in waves of invisible energy. Within hours, the upper atmosphere would disintegrate. Ultraviolet radiation from the sun, no longer filtered by ozone, would burn everything alive. Plants would die, oceans would heat, and ecosystems would collapse. Even underground, the radiation would linger for decades, making survival nearly impossible. For context, scientists believe a gamma-ray burst might have caused one of Earth's mass extinctions millions of years ago. It didn't leave craters or fire, just silence. That's the terrifying efficiency of stellar radiation. Destruction without flame, extinction without warning. If a supernova happened even farther away, say 100 light-years, we'd still feel it. Nights would glow unnaturally bright for weeks as cosmic rays bombarded our atmosphere. Satellites would fry, auroras would dance at the equator, and the human race would realize how powerless we are against the raw mechanics of the universe. And yet, astronomers continue searching for these stars, not out of fear, but fascination. They want to understand the forces that could one day end us, because in understanding them, we understand ourselves. We're made of the same matter, shaped by the same explosions, destined to return to the same dust. If a killer star ever appeared near Earth, it would mark both an ending and a revelation. We'd witness firsthand the raw cycle of the cosmos, creation born from destruction, life and death woven into the same stellar thread. The search for worlds that survive around hostile stars. In a universe filled with chaos, you'd think survival is impossible. Yet, against every cosmic odd, there are planets that endure, orbiting dangerously close to violent suns, battered by radiation and magnetic storms, but still clinging to existence. These are the survivors of the galaxy, the worlds that refuse to die. Astronomers have found planets orbiting pulsars, neutron stars, and even white dwarfs, the remnants of once mighty stars that destroyed everything else around them. These zombie planets shouldn't exist at all, yet they do. Their mere presence defies the rules of astrophysics and reminds us how stubborn life and matter can be. One famous example is PSR B1257+12, a pulsar system 2,300 light-years away. It contains 3 rocky planets orbiting a star that should have obliterated them. The pulsar's radiation would sterilize any life, yet the planets remain, silent, scarred, and unyielding. They are monuments to survival in the harshest conditions imaginable. Scientists have also discovered planets circling white dwarfs like WD 1856P534b, a gas giant orbiting so close that it should have been shredded. Somehow, it wasn't. Its orbit is perfectly balanced between destruction and stability, an impossible dance on the knife's edge of gravity. These worlds may not harbor life as we know it, but they prove that resilience is written into the fabric of the universe. Even in the aftermath of cataclysm, order can emerge from chaos. Where stars die, planets rebuild. Where light fades, matter reorganizes. The cosmos, for all its violence, always finds a way to continue. In a sense, these surviving planets mirror us. Humanity lives in a universe that could erase us in an instant. Yet here we are, evolving, exploring, learning to understand the very stars that could one day destroy us. We too are children of destruction who learn to thrive in its shadow. So perhaps the story of killer stars isn't one of doom, but of balance. For every act of cosmic annihilation, there's a spark of creation. For every world lost, another is born. And somewhere out there, among the wreckage of dead suns, new planets are forming, ready to begin their own fragile dance beneath the light of future killers. Because that's the ultimate truth of the universe. Even in death, the stars never stop creating.